Hi guys, it's the Seattle Ring Hunter. I'm here and I'm happy to announce that I have come up with a great solution for a problem that I've been experiencing with the Excalibur 2 in my dive configuration. Forgive me, I'm here on the floor. My bench is full of equipment right now. I've been testing a number of different solutions, but first let me explain to you what the issue was that had caused me to start researching and looking for a way to overcome it. And I have overcome that issue, and I think it's going to be a very elegant solution. I'm about 90% done with this, but the electronic side and the proof that this circuit design is going to work has actually been proven here, and I'll demonstrate that in a moment. So basically, as you guys have seen, doing some shallow water dives, cold water dives here in the Seattle, Washington area. We're dry suit divers, and a lot of times we're running thick dive gloves. I run a 7mm dive glove, so you got to remember I got a lot of neoprene around here, so my dexterity is limited, but my hands aren't freezing, and that's the whole point. The other thing is that you noticed in some of my videos in the past, we got a lot of silty bottoms, and so that makes the visibility sometimes quite limited when you start stirring up the bottom. I have the Anderson knob guard here. Any of you that are Excalibur 2 users and have been around a while have known that by design, these original buttons are made to break away if they take too much force, so you don't compromise the O-ring seal and flood your detector. So to overcome that, I just take it very cautiously and easy, but I'm still a bit nervous because here's the point. For backup, I actually have to save a dive or to save a search. When I'm out looking for somebody's ring or lost item, I keep the Anderson knob guard, or I'm sorry, the Anderson knob set available with me. So if I do break one of these in the field, I can replace it quickly and still be operating. But here's the whole point. I've got the Anderson, this amazing carbon fiber dive shaft on here with this knob guard. But here's the point. For me personally, when I get into silt that's about this deep sometimes, and I've got a lost ring in there, and I've got this much detection area, and I'm trying to find a ring the size of smaller than a quarter, and you could spend some time in there, even with the pinpoint mode, which is a lot more moving of the knob down here to get into pinpoint mode. When I'm diving, it's all about efficiency and saving the amount of the most efficient use of my time down there, because I'm limited because of my tank and my air. I'm not hookah diving. I'm not staying down for 3 hours with a hose to the surface. I'm full scuba, so I'm limited to a single tank. I'm a single tank diver when I'm doing this with recreational scuba dive equipment, as you've seen. So I have to be efficient, and I don't want to over rotate this knob. But what I'm getting to right now is that you can see that I conveniently have, and it is bolt snapped on so I don't lose it. This is the pin pointer that I've chosen to use, the X pointer, I believe they call it. Yeah, X pointer. There's like 2 different names for this. It's the same company. It's been real good. It's actually certified to go down at depth. I enjoy using this underwater, but if I let go of this, it floats to the surface. So therefore, we bolt snap everything whenever we're diving. Clip it on, or else you might lose it. It's a critical piece of the equation that I need to have. The whole point here is I'll demonstrate. If I turn this on, anytime the Excalibur is on, they have what they've terminology they use, or their definition is BBS technology. You can dig more into what type of metal detector this is, and a lot of you already know. But the point being is that when this is on and you turn on just about any pinpointer, and I've gone to my local metal detection shop and I have tested almost all of the modern pinpointers, the issue still persists that you can't run both of them at the same time. It's kind of unfortunate, but we're not going to change the design technology of the Excalibur 2. We're not going to change much of the pinpointer technology. So to overcome this, and I'm just going to demonstrate right now. When I turn this on, you'll hear it, and it will be consistent like that. Of course, on my floor I may have some metal screws or nails, but anyway, at the ring, you'll now listen when I turn on the pinpointer. The pin pointer for one is going crazy. It keeps going, and it's not supposed to be doing that at all. It's out in the middle of the air. It should be completely silent. The headphones are going crazy. So let's turn off the pin pointer. Let's turn off the Excalibur. And here's the pin pointer. That's the way the pin pointer until it comes across metal. So as you can see, this little taking the time to explain the situation clearly up front, the issues that I've been having. They're not showstoppers. They're just I'm over rotating this thing. Anytime especially if I'm in a junky marina where there's a lot of metal items that I need to clear, and I'm going to dig them out and collect them and put them in the bag, the trash bag, or if it's something worth value, collecting that. I'm going to be turning this on and off quite a bit. So if you look here, we put on the 7mm dive glove. We're underwater. We're trying to be efficient, and we're sitting here, and I've got the knob guard because I don't want these switches to get banged and broken, and I have to turn this knob all the way up to the point where the volume is almost at 85–90%. Well, maybe a little less, but you know, I like to run it about there. All these other settings I leave alone, so I'm constantly turning this on and off underwater with limited dexterity, cold. You got the environment. The less I have to manage as far as the equipment underwater, the better the whole safety equation becomes too. Try to keep it as simple and streamlined as possible so we're not task overloading. So here we go. You got the battery pack, and I started thinking about it. We know that power is switched. You can hear it. There's a physical switch in this potentiometer. So basically when you switch it, power is applied to the metal detector, and then when you turn it up, you actually hear it. And this is a tough knob. This is not an easy moving knob. It's got a bit of resistance because there's O-ring seals in there trying to keep the water from flooding out the inside of this. I understand that, so it makes it a little bit more. You have to get a good grip on it if your hands get a little cold or whatnot. So, you know, there's some challenges here. I mean, they're not showstoppers, like I said, but we can do better. So the whole thing is to come up with a way, because the battery pack is right here. If we look at the battery pack, if you're not familiar with it, you basically have this is just a screw, a machine screw. It's not electrically part of the circuit. It's just for keying it so you don't put it in reverse polarity. And you got your plus 12 volts and your ground. And it's a nickel metal hydride 12 volt battery pack. And basically that's what it is. So the whole point was, if we demonstrate here, we'll take it one step at a time so everyone can follow along. Basically, we just want to take the power, remove the power, turn the power on, remove the power. So what's an easy way to do that? We want to keep the water IP rating of this container here, which is the battery pack. It's separate from here. We want to keep that completely watertight. So a lot of things that we've seen in the past with the underwater gear is that sometimes they use a magnetic reed contact. Basically, you got a switch in there, just like your door alarm contacts you've seen for years over the doors and buildings and homes, alarm systems. Basically, you bring a magnet close to it and the switch closes. Take the magnet away, the switch opens. I actually had this wired in. The first switch I bought did not handle the inrush current of when I turned this on enough, and the actual contact, the first one, this one here actually was the first one, it actually welded itself or stuck. It's stuck closed now. It doesn't even open, so it's always on. I got another one with a little bit of a higher current rating for the inrush current, and this was the interesting concept. So the idea was to have this inside of the plastic housing inside of here, so it was water tight, and then I wasn't going to make any compromise to this plastic, and I was just going to make a knob with a magnet in it that was a push-pull mushroom to get it, and that's been used in other dive applications. It's actually being used on some of the DPV dive scooters and such for kill switches, which is a really good application. But you got to remember, I quickly learned, and I wasn't sure, that's why I had to do the testing. Metal detector's got your EMI coming out of it, it's sending out a signal. So what happened was really crazy. I actually had it in the open position, all like this, turned on the power. The detector didn't come on because this was a normally open switch until the magnet came. It closed the contact and it was running. I took the magnet away and it stayed on, and I was like, oh my goodness, I've just welded the contacts to this switch again. And I turned off the power I turned the power back on and the machine didn't come back on. The switch opened back up. I put the magnet on it, close the switch, take the magnet away, and it stayed closed. The signal coming out of the metal detector actually was enough in the circuit to cause this switch to be energized, basically with the magnetic, closing the magnetic contacts, the reed switch. So out with that. That technology is not going to work. We had to think outside of the box again, kind of reach out to the community and see what else has been used. I looked at a number of different applications across the internet, and I came across the piezo electric switch, which has been used in some dive lights. And if you've ever seen one, I'm going to bring an example of that over here now, and I'm really excited about how this is operating. Bought another battery pack to do my testing on. I'm going to compromise this one. 12-volt battery pack. I'm going to just bring it out of the case here, basically, and what you have here is a piezoelectric switch, and we have a control board here. But basically, this is a piezoelectric crystal. Basically, whenever it gets flexed or bent, it actually generates a little bit of a voltage, and that voltage can get translated to a contact switch, basically, and that's what we needed. But this contact switch, when you push it, it just sends out a small little voltage, and its internal circuit actually makes it so it is a like a dry contact, open and closed. But that's not enough, because we need a flip-flop circuit, because you want to be able to, with that pulse, it's a real small pulse each time you push it. It's not constantly, it's not push it once, constantly on, constantly off. So that's what this little circuit board here. This is a push button circuit by Adafruit Technologies. I was actually going to design my own and got online and said there's got to be a better way. And if you're ADA Fruit, I believe.com, look them up. They've been around for years. And Lady Ada, the owner of that company, I believe they're in New York. She's amazing, electrical engineer, and they've got all their in-house pick and place surface mount electronic circuit board production facility going on. They do a lot of do-it-yourself jobs, and the whole electronics community, the maker community is what I was trying to say. Internet of Things, they're real big on all those projects. They have all the expensive equipment, and she actually generated this board and manufactured it a few years ago, and it's for sale in her store online if you go to adafruit.com. And this is an amazing little board for $12 with shipping or something. I think it came out to. I couldn't have developed and designed that myself without going through a lot of extra time. So basically how it works here is, and you can see, and she's actually put an LED on it, which is a critical part of my solution. The quick thing I'll mention is that when you take this connector off of the non-modified original Excalibur 2 battery pack, these probes or these contact sockets go directly to the battery. There's no electronics in between it. So when you want to go to recharge that battery, they provide this from MindLab, and it basically plugs in there. As you're all aware, any of you that have this metal detector know that you plug in the charge, plug it in the wall, and you're good to go. Come back later and it's charged up. Knowing this, I didn't want to get myself caught in a catch-22 where if I had this thing wired up with no LED on it, not knowing what position it's in, and I have it plugged in, and I have it sitting there for a couple hours and come back later, I'd have to basically, to confirm, I need to go and take a voltmeter and test the voltages to see if it actually charged, because if it was left in the open position, unbeknownst to me, no charge is getting to the battery, and that would screw you on time. It could cost you a lot of grief not knowing that. So here's how this operates. This is connected up right now. This is just a 9-volt snap that you see on a 9-volt battery snap that the MindLab is used in their circuit design. The first time it'll power on, but basically if I push here, just pressure. It's not inductive like your cell phone, which is really cool. It's pressure. It's a piezoelectric crystal underneath this aluminum housing. This switch, by the way, has been proven for military use. It's been proven in marine environments. It's been proven at depth. It is corrosion, darn near corrosion proof almost, but it's very corrosion resistant. It's made to be actually in marine equipment and harsh environments. It's been potted with a potting compound, so this is all sealed off. Here's my total intent on this design, circuit design. When this all goes back into here, I'm just going to make a small hole, and I'm going to get some type of a plastic, I don't know if I'm going to use a Delrin, or like this as an example. I'll get a piece of Delrin and have it machined, or if I'll just find some other piece of plastic that's sufficient, it'll be somewhere where the switch will be inside of it. Switch will be in this orientation. So we'll have a piece of plastic basically just as a demonstration proof, and this would be inside of the switch, obviously be all nice and professional there. And then what I'll do is I'll put a small hole here, put that there with that whole switch assembly in there, and with the hole and a syringe I will inject the proper, there's a very specific and proper type of two-part epoxy that is used for marine use, and for if I use Delrin plastic, most of the epoxies will not adhere to that, but I've already found and sourced a product that will actually work for that, which is amazing. Palm and some of the other plastics, like Delrin, is self-lubricating, that's why it's so good for machining, but that also, if you got self-lubrication of that, some of the adhesives will not adhere to it, so you have to be very careful, and you have to do your research before you start just going to your hardware store and getting basic two-part epoxy and slapping it on there, and you put it on there, and next thing you know the button's falling off and you got seawater going inside, trashing your battery pack, and you're done for the day, and you go back and you just wasted an expensive battery pack. Not too expensive, but still, you don't want to go down that road. Do your homework if you're going to do this yourself. I'm not here to do a complete DIY and all the very specific details. I'm just here to report that I've come up with this solution. I'm also not here to say that I'm doing these modifications at this current time. This switch here by I think it's EverSwitch is the name. You can look it up yourself. I had to find this on eBay. Someone had some overstock and they're selling it. You might run into some issues trying to actually source these switches. They're usually sold 500 pieces or more for manufacturers. They supply to manufacturers. I just happened to find the one that I was looking for. It's this diameter on this one is 22 millimeters at the thread hole here. So that is the size of it. This thing is amazing. They make another one with an LED that's actually on the face of the switch, but I didn't need that. It wasn't easy to even find that on the open market, or the third party market, I guess you'd like to refer to it, if we're trying to find somebody selling singles. I just did this for my own use, and I wanted to share it with you guys because I'm excited that it actually works. So here we go again as in the demonstration. And so we get to that point. Just to kind of keep this together, I'm just going to slide it in here temporarily. The reality is that this button would be coming out. It will be coming out here on this side, like I explained earlier. Wires all inside. We're going to connect this up, and we're going to do a live demonstration on how awesome this solution is. The LED is bright enough in this plastic. It's great. I can see it. So when I turn on, the expectation right now is there's no LED light on. You don't see any LED light, so we don't expect this to come on, and it's not going to come on. I'm going to run it up there a little bit, so when we turn it on, we should hear something. And we do. Off. It's off. On. Off. I mean, I'm just getting a little bit excited here because this has been a couple months and trying to get the proper solution here to work. Here's the really cool part too. I mean, it's just efficient. I could turn that off with the thumb, turn on the metal detector, go back to work. It's going to be down here. I'm just going to go push it just like this. It's going to be down here. I'm just going to, like that. I'm going to push it back on. Now, if that isn't amazing, I don't know why they didn't think of this before in the front end of building this machine. A lot of times these things come to realization after you've been out there using the equipment and then you're in a specific application. So I'm a real big fan of using the pinpointer because I'm dealing with a lot of silt and a lot of limited visibility. I can get the pinpointer down in the silt and actually find the ring and just scoop it up. Here's another thing I wanted to demonstrate in this video real quick. This is going to be awesome. I can leave all my settings exactly where I want them throughout the whole dive. This is amazing, right? The whole dive. And with this type of a button, even with the neoprene, easily, you have to push it right in the middle, and it's not hard. It's right in the middle of it is where you got to get the pressure on it, and it works really well. So that is what I have to report at this time. We'll do a little update here in a while after I go ahead and get the proper piece of plastic or mounting and 2-part epoxy, knock the hole through there and get this solution back together and get this all packaged up and on the machine. One last thing I wanted to mention, this circuit, which is also another critical thing. If you're going to design a circuit to be a push button, like a flip-flop switch for a push-pull or for a on-off type of a switch for a battery, it's really low current. It only, I think it's less, it's essentially zero. It's pretty low. It's micro, I think it's a half a microamp of draw when it's not turned on. Over the course of a few days, I didn't lose any voltage, really, nearly anything at all as far as the battery voltage. So it's more than suited for battery projects, this board from Adafruit. So you can look that up if you're actually seriously interested in trying to do something like this on your own. Have fun trying to find this button though. It could be a challenge. I've talked to the manufacturer directly, and there's certain level or quantities, because they're selling directly to major suppliers and basically manufacturers. So this application has also been used on the, I think it's the Light guys, Dive Light. They use one of their branded switches, and I couldn't be happier. And I haven't got this thing in the water yet and got it under completely glued up and mounted to the outside of this. But I think it's going to be a wonderful solution. Never stop with your ideas. Keep following them through, and eventually you can come to a great solution. And we'll go ahead and put this out and share it with everyone. This is awesome. So cheers. And if you've lost anything in the Seattle area, please give me a call, the Seattle Ring Hunter, at 206-618-8194. And if you know of anyone that's lost something, definitely tell them to get to the ringfinders.com directory listing so they can find someone in their local area, because there's a lot of great people across the country that are like myself. They're at the ready to go out and do a search for your lost items. Cheers, guys. Happy New Year's 2020. If you've lost your ring or special item of value, please get in touch with me at the SeattleRingHunter.com as soon as possible so I can arrange to do a search for you.